So this is marking period 4 review, part 4, questions 151 through 200. Make sure you've got your reference table and a calculator. Okay, so number 151, which half reaction can occur at the anode? So the fat, red cat, ate an anorexic ox. So the anode is oxidation. Oxidation means the loss of electrons. So we want to have our charge go up, and we're losing electrons. So in part A, we are gaining electrons. In part B, it looks like we're gaining electrons, but this charge is going up, so no. Part C, we are losing electrons, and part D, that's what we want. Oops. So part C is what we want. We're losing electrons, our charge is going up, so that would be at the anode. Right, 152, when a voltaic cell operates, ions are moving through the salt bridge. Electrons through the wire, ions through the salt bridge. Which device requires electrical energy to produce a chemical change? That would be an electrolytic cell. Electrolytic needs electricity. Electrolytic cell differs from a voltaic cell because an electrolytic cell generates its own energy? No, it requires it. Requires an outside energy source for a spontaneous chemical. No, if it requires outside energy, it's not spontaneous for a non-spontaneous reaction to occur. Here we have an electrolytic cell, it tells us. We have a battery, we have everything else. We have the half reaction. What is happening for reduction? Gaining electrons is reduction. This is the fat red cat. So if you're looking for reduction, it has to be cathode. And who's going to be getting larger? Every single time you see electrolysis here, electroplating, it's going to be the key getting fatter. It's going to be the fork, the spoon, the whatever. So it has to be A, which is the cathode, which is choice B. 56. When the electrolytic cell is in operation, it needs electrical energy to create the chemical reaction. There's no light involved anyways. Chemical to electrical, that's the voltaic. What is an electrolyte? An electrolyte, first of all, these are acids, bases, and salts. These are not alcohols. They are any substance that produces electric currents. It conducts an electric current as a solid? No, you need mobile ions. When an electrolyte dissolves in water, the resulting solution conducts electric current. Choice C. Which can represent hydrogen ions in aqueous solution? Hydrogen ions, aqueous means water, so that's H3O with a plus. Very good. Me. 159, what is an Arrhenius acid? So to go to the reference tables, acids and bases. Acids are table K, bases are table L, and table M is the indicator. So when they're asking for an Arrhenius acid is any substance that produces H plus in solution. So generally they're saying, hey, look here. So any of these on table K with an H plus. So this A, you might be tempted to choose, but there's no H plus. It's 0. So in this one we have H plus, Cl minus. It's also called hydrochloric acid on reference table K. 160 is asking for an Arrhenius base. So you're looking for something that's on table L. You find calcium hydroxide. That is a choice. You choose it. Be aware that Arrhenius bases have hydroxide. This looks like hydroxide, but this whole thing is an organic acid. It's also on table K though, so you shouldn't have to worry about it. What is the color of brome cresol green? Indicator in a solution with a pH of 2. So brome cresol green, pH of 2. So brome cresol green is here. 2 is below this part of the range, so it's going to be yellow. Some of those other colors don't even exist for that indicator. Compared with a 1 liter aqueous solution with a pH of 7, a 1 liter aqueous solution with a pH of 5. Okay, so remember the pH scale goes from 0 to 14. These are acids. These are bases. So as you're coming from a 7 to a 5, that's more acid. So which of these names means acid? Well, that's hydronium. Hydroxide is the OH minus found in bases. So you say to yourself, okay, so it's a 5 versus a 7. That's 2 jumps on the pH scale. Each jump is 10. So 7 to 6 is 10. 6 to 5 is 10. So 10 times 10 is 100. All right, so we got a reaction equilibrium. If an acid is defined as an H plus donor, which is, wow, they gave that to you? That's pretty awesome. Which is the, what is the acid of the forward reaction? So this is the forward reaction. So NH3 becomes NH4 plus. That means this gained, which means H2O becomes OH minus, which means that gave away. So it has to be H2O liquid. Phenolphthalein is pink in an aqueous solution having a pH of, so phenolphthalein would be pink anything 9 and higher. So 9 and higher would be D. Given the reaction, the water molecule acts as a base. So the bad theory of Bronsted-Lowry, bases accept, acids donate. So bases must accept, but accept what? Protons. That's Bronsted-Lowry theory. A lot of times they call it the alternate theory. Which equation represents neutralization? Neutralization, acid plus base yields salt and water every single time. So do you see any that contain an acid? Here's an acid. And a base. This is a salt, which by the way, is just an ionic compound in water. Choice C. In which laboratory process is a volume of solution of known concentration used to determine the concentration of another one? We've got deposition, distillation, filtration, and titration. So deposition is when a gas goes straight to the solid phase. Distillation is separation of mixtures, liquid mixtures based on boiling point. Filtration is separating things out based on particle size. Titration is the answer, and titration is found on table T right here, and I'll change colors. So titration, molarity is concentration. So if we know the concentration of one and we know the volume of both, then we can find the concentration of the other. So titration is D. In a titration, 10 milliliters of a 0.0750 molar HCl aqueous solution is exactly neutralized by 30 milliliters of the KOH. What is the concentration of KOH? So concentration of KOH would be the molarity of the base. If you didn't know that KOH was a base, you've got reference table L. So molarity of the, by the way, we just looked at the formula. Molarity of the acid is 0.0750, and that's going to be multiplied by the volume, is equal to 30 is the volume of the base, and I don't know this. So with some algebra, let me grab my calculator. We've got 0.0750 times 10, just giving us 0.75 equals those two things. So we're going to divide this by 30. And you're going to get 0.025. And so that's 0.0250. They're keeping some sig figs going on there. Okay, another titration. So we're looking for a molarity of the acid this time. So 20 milliliters of 0.150 is equal to 24 milliliters of, I don't know. So calculator, 20 times 0.150 gives me 3 equals 24x divided by 24. And you get 0.125 molar. Spontaneous nuclear decay means one reactant. This is the only thing on this side. Everything else has two. Which emission causes the atomic number of the nuclide to decrease by 2 and its mass number to decrease by 4? So which is 4 over 2? Back on the reference table. The nuclear tables are table N right here and table O right here. Who's 4 over 2? That would be alpha. What is X? So on the left, the reactants, we have mass of 232. On the right, we've spit out an alpha. So we have 228. And then we have 90 protons. 2 of them are gone with the alpha, so we're down to 88. Now, 2 of them have those numbers. So how do I figure out what is the answer? Well, I'm going to go to periodic table. And I'm going to see who has atomic number 88. It's going to be right here. Sorry, it's twisted to the side. It's radium. There you go. Which particle has the least mass? Alpha, beta, neutron, proton. Table O. Alpha has a mass of 4, beta has a mass of 0, neutron has a mass of 1, proton has a mass of 1. Beta particle. The mass is up here, protons is here, and there's your symbol. Which has the greatest penetrating power? Alpha is the weakest, then we've got beta, and then we have gamma. So it goes alphabetically, weakest to strongest. Alpha can be blocked by your skin or a piece of paper. Beta can be blocked by aluminum. Gamma can only be slowed down by some lead. What is the mass of an original 5.60 gram sample of iron 53 remaining unchanged after that many minutes? So we can make a chart. We've got mass and we've got time. So originally the mass was 5.60 grams times 0. Now I need to know iron 53's half-life. So iron 53's half-life is 8.51 minutes. So after one half-life is 8.51 minutes. And so let's go to the calculator. So the time is going to increase, but the mass is going to drop by half. So divide that. So we get 2.8. And then half of that is going to be 1.4. So then I take my time, 8.51 plus another 8.51. It's going to be 17.02. We're going to stop when we get to 25.53. So 1.4, take half of that, you get 0.7. And 17.02, we're going to add another 8.51 days. And we get, you know what? We get the answer we want, 25.53 minutes. So 0.70 grams. Which radioisotope has the fastest rate of decay? Because I need to look at table N and the choices, I'm not going to flip to that on my screen. I'm just going to look. Carbon-14, half-life is 15 years. It's pretty long. Calcium-37, 182 milliseconds. That's pretty short. Iron-53, we just had that, 8.51 minutes. And potassium-42 is 12.36 hours. By the way, if you didn't recognize the Y, the MS, the MIN, and H, all of those are on table D. Those are the units. So fastest rate of decay is calcium-37. Which type of reaction is going on here? First of all, it's nuclear, so it has to be a transmutation. Neutralization, we talked about earlier. Acid plus base yields salt and water. Polymerization, you've got lots of long organic carbon chains. A substitution is when you have hydrocarbon or something with something else sitting on the bench and you flop it out. What's going on here? So I see big, mass of 235. That's big. A little neutron is going to hit it, ba-ding, and then you have all these other things. This is called nuclear fission. 178. Energy released by a fusion reaction is produced when? Well, it's nuclear. So, and the whole point is about energy. So it has something to do about energy. So you're taking the mass that was stored in the nucleus and we are converting it to energy. We talk about E equals mc squared. This is Albert Einstein. This is what he was talking about. Which type of nuclear reaction do two light nuclei combine to form a heavier nucleus? This is called nuclear fusion, fusing together. 181, what is X? So on the right we have 1 plus 256, so it's 257, which means this has to be a 4 to get 257. This is a total mass of 101, which means this has to be a 2. So 4 over 2, if you look on table O, it's an alpha particle. Which statement explains the energy in the energy term in this reaction? So it looks like we've lost some mass. So why would you write that it's gained? The number went down. And why did we lose some mass? Because it converted mass to energy. Albert Einstein. Which radioisotope is used to determine the age of once living organisms? It's carbon-14, organic, living. Which radioisotope is used in dating geological formations? So iodine is I-Thi. So there it is. This is actually 186. Calcium 37, uranium 238, francium 220. There's a few that we just need to know. Uranium 238 is for rocks. Cobalt 60, I'm sickly. That's 185. We talked about 186. I-Thi. Iodine, thyroid. Radioisotope. Okay, so if you're going to put something radioactive in your body, do you want it there for a long time? No, it could be harmful. So short. Do you want it in your body for a long time? No. You want it out, out, out. So short half-lives, quickly eliminated. Which phrase describes a risk associated with producing energy at a nuclear power plant? How about getting rid of the waste, nuclear waste? See. The modern model of the atom is based on the work of one scientist or many scientists, and it's taken a long, long time. We're talking ancient Greece for the work of Democritus, all the way up to the 1900s. Read the graduated cylinder. So looks like the scale is by 1 milliliter. This is right on 35, but we always estimate one beyond. So 35.1 or 0, excuse me. Accurately measured volumes of acid and base during a titration, that would be considered a burette. This is called a grad cylinder. This is an Erlenmeyer flask. C is a burette. Note we have the valve here. And D, I don't know what that is. Looks like a super long, I don't know, grad cylinder. 192, which is used for taking things, crucible. So we need crucible tongs, which is D or A. And then the crucible is placed on the clay triangle. Aluminum sample is a mass of blah, 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 blah. We're going to calculate the density. No, volume. Oh, yeah. So we have density. So first of all, density equals mass over volume. It's on table T. Density is 2.70. But over 1, excuse me. Mass is 80.01. Oh, you know what? We don't actually have to solve this. But remembering sig figs, the fewest number of total sig figs. And I didn't even write that right. So this has 3 sig figs. This is 4. So we are going to use the fewest number, which is 3. Which unit is used to express pressure of a gas? So back on the reference table, you look here on D, pressure of a gas. Here's pressure. That's all I see. Pascal. D. Which quantity of heat is equal to 200 joules? So we need to look from joules to kilojoules. So back on the reference table, we have kilo is 10 to the third. That's 1,000 times larger. So a lot of people don't like dimensional analysis, but if I'm going to go to kilojoules, 1 kilojoule is equal to 1,000 joules. Get rid of those. So 200 divided by 1,000. which is the same as saying 123.200 kilojoules. The percent error. Okay, so this one's a lot. I remember this question. So first of all, percent error, that formula is on the reference table. You can see we've really been through a lot on the reference table here. Percent error right here. Measured minus accepted over accepted times 100. So it says the student measured it to be 2.85. We need to figure out what the accepted is, which is on table S. So you know what? Actually, you go to table S. I'm not going to look it up. It's going to be sideways anyways. So aluminum's density is 2.70. So we're going to do 2.85 minus 2.70 over 2.70 times 100. Remember, if you stopped there, that's what we call a correct numerical setup. So 2.85 minus 2.70 is 1.15 divided by 2.70, and then multiplied by 100 is 5.5 repeating. So that's going to be 5.6. The wavelength of the violet colored light is blah, blah, blah. We need scientific notation. So first of all, any number less than 1 is going to have a negative exponent. So then we're just going to move our decimal place 1, 2, 3, 4, 5, 6, 7 times. And there it is. Until you move the decimal place until you get a number that's between 1 and 10. This is a very tricky one. So we have 3.8 times 10 to the third kilometers. So that would be 3,800 kilometers. And so you'd be tempted to choose that. But notice it's kilometers and this is meters. So there's an additional step here. If you remember that in 1 kilometer, there are 1,000 meters. Kilo is 10 to the third. That's on table D. So that's going to be 3,800,000, part D. All of these are safe except wearing goggles? No. Leaving boiling water unattended? Yes. Which means 1,000? We just talked about this several times. Kilo. Okay, we did it. If you have any questions, please reach out. Thank you.